Hi friends, I'm Davat, and in today's section, we are going to be learning elementary system, solving linear equation using the elementary system. So let me introduce you to some basics of elementary system. And okay, so what do we call a linear equation? This is called a linear equation. A linear equation. Okay, let's say we have ax1 plus bx2 plus cx3 equals to 1. So this is a linear equation. So let's have multiples of this. So cx3 dx1 plus ex2 plus fx3 gx1 plus hx2 plus ix3. So equals to 2 equals to 3. So this is called a linear equation. So to be able to solve this, to be able to get the x1, x2, x3 for all this, we are going to be using the elementary system to solve the linear equation. Elementary system. So we're going to be using the elementary system to solve the linear equation. And what's the first step of using the elementary system? The first step is writing out your coefficient matrix. Coefficient matrix. The second step to solve linear equation using the elementary system is writing out your output vector matrix. Output vector matrix. The third step is writing out your augmented matrix. Augmented matrix. That's the third step. And the fourth step is making the augmented matrix an upper triangular matrix. Upper triangular matrix. So let's begin with the first step. How do I write my coefficient matrix? So in this linear equation, what are the coefficients? These are the coefficients. The coefficients are A, B, and C. The coefficient of x1 is A, the coefficient of x2 is B, the coefficient of x3 is C. So we are going to be writing out the coefficient matrix, and the coefficient matrix is going to be in this form. The coefficient matrix is going to be something like this. I have A, I have B, I have C, I have D, I have E, and I have F. I also have G, I have H, and I have I. So these are my coefficient matrix. These are the coefficient matrix. After we are done writing the coefficient matrix. The second step is writing out the output vector matrix. So how do we write the output vector matrix? Output vector matrix. How do I write this? These are my output vector matrix. This equation is equals to this. This equation is equals to this. And this equation is equals to this. So these are my output vector matrix. So my output vector matrix are 1, 2, and 3. These are my output vector matrix. So we are done with the second step. The third step is to write the augmented matrix. The augmented matrix. And the augmented matrix is always written in this form, AB. And this is my A, this is my B. The coefficient matrix is the big A, while the output vector matrix is the small b. So my augmented matrix is always written as AB, which is the combination of the coefficient matrix and the output vector matrix. So my augmented matrix is going to be something like this. I have A, B, C, D, E, F, G, H, I. So I'm going to put it A, B, C, D, E, F, G, H, I. And to partition the coefficient matrix from the output vector matrix, I'm going to use a slash, or you can use this or a slash. So what are my output vector matrix? I have 1, I have 2, and I have 3. So this is the augmented form of the matrix, of the output vector matrix and the coefficient matrix. The combination of the output vector matrix and the coefficient matrix is the augmented matrix. So we are done with the third step. So the next step is to make the augmented matrix an upper triangular matrix by performing some operation. So what do I mean by upper triangular matrix? Upper triangular matrix. So to make this an upper triangular matrix, look at this. We have a diagonal. There's a diagonal here. So to make this an upper triangular matrix, this G must turn to 0, this D must turn to 0, and this H must turn to 0. So after I turn all these letters or number, whatever it is, to 0, it is going to be an upper triangular matrix. An upper triangular matrix. So it's going to look like something like this. We have A, B, C, 0, E, F, 0, 0, I. This is an upper triangular matrix. And also we can have a lower triangular matrix. What is the lower triangular matrix? The lower triangular matrix is turning the B, C, and F to 0, 0, 0. And to do this, we are going to perform some operation on the matrix, on the augmented matrix. To obtain 0, 0, 0, we cannot just turn it to 0, 0, 0. We have to perform some operation on the matrix to obtain 0 here, 0, and 0 here. So let us look at an example that we are going to be solving. Let us look at an example. So I have an example here. So I have solved the linear equation. Linear equation using elementary row operation. Using elementary row operation. So I have minus 3x1 plus 2x2 plus 4x3 plus 4x3 equals to 12. I have x1 minus 2x2, x1 minus 2x2 equals to minus 4. And I have 2x1 minus 3x2 plus 4x3 equals to minus 3. So he said I should solve the linear equation using the elementary row operation. These are the linear equation. So as you've said, he said the first step to solve an elementary system, the first step is to write out your coefficient matrix. My coefficient matrix. The second step is to write out the output vector matrix. The third step is to write the augmented matrix. And the fourth step is to write the is to make the augmented matrix an upper triangular matrix. So after making it an upper triangular matrix and we are done solving, it's as simple as that. So let us write out our coefficient matrix. My coefficient matrix is equals to what? So my coefficient matrix, my x1 here is minus 3. I'm going to put minus 3. My x2 is 2. is plus 2, which is 2, and my x3 is 4. I'm going to put it 4. I'm going to close this. My x1 here is 1. I'm going to put it 1. My x2 is minus 2. Minus 2. And since we don't have x3 here, my x3 is 0. Do you understand? There's no x3 in this place, so my x3 is automatically 0. So in the third equation, in the third linear equation, we have my x1 to be 2, we have x2 to be minus 3, and we have x3 to be 4. And I'm done writing my coefficient matrix. This is what it looks like. So I'm done with the coefficient matrix. Writing out the output vector matrix. The output vector matrix. This is my output vector matrix, which is going to be equals to 12 minus 4 and minus 3. 12 minus 4 and minus 3. That is my output vector matrix. And the third step is writing out my augmented matrix. My augmented matrix. Let me clean this part. My augmented matrix. Augmented matrix. And my augmented matrix is going to be the combination of my coefficient matrix and the output vector matrix. And what is my coefficient matrix? So my coefficient matrix are minus 3, 2, 4, 1, minus 2, 0, and 2, minus 3, 4. I said we are going to partition the coefficient matrix from the output vector matrix using a slash or a double dot like this, a double dot, a double dot. But let's use a slash. So what are my output vector matrix? 12, I have 12, I have minus 4, I have minus 3. And I'm going to close it like this, and I'm done writing my augmented matrix from the coefficient matrix and from the output vector matrix. And after that, what is the next step? The next step is to make my augmented matrix. An upper triangular matrix. And I said to make the augmented matrix turn to an upper triangular matrix, we have to turn the lower part of the matrix to 0, 0, 0. So to turn this lower part of the matrix to 0, 0, 0, we have to perform some operation. We have to perform some operation on the matrix to turn this to 0, 0, 0. Stay with me till the very end of the video to understand it very, very well. This is kind of tricky, but it's not hard. So let us get into it. First, let me say this is my first row. I'll name that row 1. This is my second row. I'll name that row 2. And this is my third row. I'll name that row 3. I will do something by interchanging row 2 and 3. I want to interchange. I want to make my row 2 to become row 3. So I will just switch this row 2, row 3 to row 2, and I'll switch row 2 to row 3. That's what I want to do. So let's go. So I'll still write this one, minus 3, 2, 4, slash 12, 12. And I said I want to interchange this. So I'm going to write all of this to be my row 2. So it's going to be 2, minus 3, 4, and minus 3 here. I'll close this. And I have my row 2. I said I want to make my row 2 to be my row 3 and my row 3 to be my row 2. So I would say my 1, minus 2, 0, and 4 should be my row 3. So I have 1, I have minus 2, I have 0, and I have minus 4. So I'm done with that. That's the next step of solving linear equation using the elementary system. That's the next step. So let us go. So I will have to make this matrix, an upper triangular matrix, in order to get a solution for the linear equation, I'll have to make this an upper triangular matrix. And to make this an upper triangular matrix, I'll have to perform some operation on it to make it an upper triangular matrix. So let's go. So as I said earlier, I said this is our row 1, this is our row 2, and this is our row 3. So I will start with this. I'll start with this. I want to make this 0. So to make this 0, I will say performing operation on row 3 such that, so I'll just say my row 3 multiplied by 2, my row 2 multiplied by 1. Where did I get that from? This is 1, and this, I multiply this row by this, which is not going to be obvious in solve. 1 R2 is still R2, so, and I multiplied my R3 by this 2, and that's all. So I'll now say, to make this 0, I'll say my 2, my operating, taking operation on row 3 such that 2 of row 3, I've told you where I got that from. 2 of row 3 minus row 2 is going to be my new row. Do you understand? It's going to be my new row. So let's go. I'm going to open a new bracket. I'm going to write this back. It's going to be minus 3, 2, 4, slash of 12. I'm going to close it like this. I'm going to close it like this. And I'm going to write the second one too, which is going to be 2 minus 3, 4, and minus 3 here. So I said taking operation on row 3 such that 2 of row 3 minus row 2 is going to be my new row. My new row. So let us take the operation. So 2 of row 3. What's my row 3? What's on my row 3 here? So I have 2 of 1 minus what's on my row 2? That's 2, and that's equals to 0. So my first number here is going to be 0. Do you understand? So it's not hard, it's just kind of tricky, and it's not tricky, it's just simple. So let us get into it. I've done the first part. I'll do for all of this. I'll do for all of this to make that upper triangular matrix. So I have 2 of minus 2 minus 3. That's plus 3. Do you understand? Row 3. My row 3 should be my new row. My new row should be row 3, which is going to be, I'm going to perform an operation on row 3 such that 2 of row 3 minus row 2 is going to be my new row. And I've performed an operation which makes me get this 0. And why I want to make this place 0, and I'll turn this place also to 0 and this place to 0, is because I want to make this an upper triangular matrix, as I've said earlier, to be able to get a solution for this linear equation. So this is 0. So I have this. So 2 times minus 2, that's minus 4 plus 3, and that is equals to minus 1. So this place is going to be minus 1. Minus 1. So let's continue. Let's continue. So I've done for these two. I've done for this. So I'll say 2 of row 3. What's my row 3? That's 2 of 0 minus, what's my row 2? My row 2 is this 4, which is going to be 4. So 2 times 0 is 0 minus 4. That is equals to minus 4. So I'm going to have minus 4 in this place. What's the next step? The next step is to make this, is to perform operation on this side too, which is going to be this. And I said performing operation on row 3 such that 2 of my row 3 minus row 2 is going to be my new row. So let's go. So I said 2 of row 3, 2 of, what's my row 3? My row 3 is minus 4. This is row 3, and this is row 2. So my row 3 on this side is minus 4, and I'm going to put minus 4 minus, what's my row 2? Minus 3, that's plus 3, minus 4, no, so there's a negative sign there, so minus, going to bracket minus 3, so that's going to be plus 3. So I'm going to have 2 times 4, which is minus 8, plus 3, which is going to be equals to minus 5. So I'm going to have minus 5 in this place, and I'm done performing the first operation, which I've transformed the number here to 0, from 1 to 0, you understand, and there's a change in all these numbers, so I've performed operation on them, which changed them to this state. So let's go. So the next one I want to make is 0 is this 2. So I'm performing operation on row 2. So I'll say performing operation on row 2 such that, so let's do the stuff. Let's try to avoid this row 3. This is my row 1, this is my row 2, and this is my row 3. So I said we should try avoiding this row 3. And why did I say that? Because if we perform an operation, we want to perform operation on row 2. If we perform an operation on row 2 and row 3 again, it's going to affect this 0 and turn it to number, a particular number, and everything is spots like that. So we just have to neglect this row 3 and focus on this row 2 and row 1. So what will I say? I'll just say 3 of row 2 and 2 of row 1. So let's test it if this works. So I'll just say performing operation on row 2 such that 3 of row 2, 3 of row 2, 3 of row 2 plus, you just have to manipulate in this place to get your answer, to get your 0. So 3 of row 2 plus 2 of row 1, 2 of row 1. So let's check if this works. And if it did not work, I'll have to change this sign to negative. Do you understand? So 3 of, what's my row 2? This is my row 2, which is 2. It's 2 plus, remember our aim and objective here is to turn this 2 to 0. So 3 of row 2, which is 3 of 2 plus 2 of row 1. What's my row 1? Minus 3. Minus 3. So 3 times 3 is 6. 6 plus 2 times minus 3, that's minus 6. Can you see? So I've gotten that to be 0. So I'm done performing the operation for this. So I'll say performing operation on row 2 such that 3 of row 2 plus 2 of row 1 plus 2 of row 1 should be my new row, which is going to be the second row that I'm performing an operation on. So let's go. So I'll draw my matrix dots. It's going to be minus 3, 2, 4, my slash, and 12. I'll put this back, and remember, I'll just have to leave this row empty. I'll just have to leave it empty because of what? I want to perform an operation on this row 2. On this row 2 to make this 2 0. Remember, our aim and objective is to turn this to an upper triangular matrix. So I'll just have to leave this row 2. And what do? I'll write my row 3, which is 0, minus 1, minus 4, and minus 5. So let's go. So performing. So let me clean this side. Let me clean this side. So I would say performing, so we said performing operation on row 2 such that 3 of row 2 plus 2 of row 1 should be my new row, which is the second row. Hope you are with me, hope you are getting it. Okay, so let us go. So I said 3 of row 2, what's my row 2? This is my row 2. That's 2, 3 of 2 plus 2 of, what's my row 1? That's minus 3. So we've solved this before and it is equals to 0. So I'll just put my 0. Yes. Can you see? We are getting it already. So we've said this place, we found this place to 0 by performing the first operation on it. This is the second operation we are performing, and we've gotten this place to be 0 too. So let's go. So 3 of, what's my row 2? That's minus 3 plus 2 of 2. 2 of row 1. And what's my row 1? My row 1 is 2. So that's equals to what? 3 times minus 3, that's minus 9 plus 2 times 2, 4. That is minus 5. So I'll have this place to be minus 5. Hope you are getting it. So let's continue. So I have 3 of row 2. What's my row 2? We are making for this side. We are doing for this side. We are solving for this side. That's 3 of 4 plus 2 of 4. So I have 4 here, and my row 2 is 4. My row 1 is 4. So 3 times 4 is 12 plus 2 times 4 is 8. So 12 plus 8 is 20. So I'm going to have 20 to be here, and that's it. So we are getting there already. We are getting there already. And this is the last part, which is this. So performing operation on row 2 such that row 3, so that 3 of row 2 plus 2 of row 1 is going to be my new row, which I'm forming already. So I'll say 3 of, what's my row 2? My row 2 is minus 3. 3 into minus 3, close bracket, plus 2 into, what's my row 1? 2 into 12, which is my row 1. That's 3 times 3 is minus 9. Minus 9 plus 12 times 2 is 24. So minus 9 plus 24, I think that should be 15. That should be 15. So I have 15 here. So what's the next step? The next step is to turn this minus 1 to 0. That is, I'm going to perform another operation on row 3. Another operation on row 3. And to do this, I already have 1 0 here. I have 1 0 here. So I would try to avoid this row 1. So I'll focus on this row 2. So this is my row 1, this is my row 2, and this is my row 3. So I'll avoid this row 1, so that these 2 zeros, they must not turn to number, because if they should turn to number, everything is spoiled already, and that is all. So we are going to get a wrong answer. So I'll avoid this row 1 and focus on these 2 rows. So let's go. So I'll say performing operation on row 3 such that, so let's do this, such that this is my row 2, so such that 5, so it's just similar to this elimination method of solving simultaneous equations. So I'm just going to say 5 of, this is 1, let me just make this 1 and let me make this 5. So let's see if it's going to work. I'll just say 5 of row 3, 5 of row 3 minus row 2. It's not making sense for me to say 1 row 2. It's just similar to saying 1x, and that's not making sense. 1x is equals to x. So there's an invisible 1 here. So I'll just say minus row 2. You get? So let's go. So let's check if this will work for me. I already know. So 5 into, what's my row 3? My row 3 is 0 minus, what's my row 2? My row 2 is 0, and that's 5 times 0, 0, 0, 0. So it's 0 already here. You get? So it's 0 already here. So let me test for the second one, which is our main objective. So I'm going to say 5 of, what's my row 3? Of minus 1 minus, what's my row 2? Minus 5. So 5 times minus 1 is minus 5. This is minus times minus, which is plus 5, and that is equals to 0. So it worked. So I'll just finalize that I should take an operation on row 3 such that 5 of row 3 minus row 2 is going to be my new row, because I said I'm performing an operation on row 3. So let's go. And this is the final step. So I'm going to write this back since I'm going to write this row 1 and row 2. I'm going to write them back since I'm performing an operation on row 3. So it's going to be minus 3, 2, 4, slash 12, close this, and 0, minus 5, 20, 15. And so I'll not write anything here, because this is the row I want to perform an operation on. So let me take off this part again. So I said performing operation on row 3 such that 5 of row 3 minus row 2 is going to be my new row. So I already know we've done this before, so let's redo it. So I said 5 of row 2. What's my row 2? This is my row 2. So 5 of 0 minus, I said 5, performing operation on row 3. This is a mistake. On row 3 such that, performing operation on row 3 such that 5 of row 3 minus row 2 is going to be my new row. So 5 of row 3, what's my row 3? My row 3 is 0. 5 of row 3 is 0, and minus 5 of row 2, which is 0 2, and that is equals to 0. So the first part here is going to be 0. Can you see? That is why I said we should just let our area of concentration be on this row 2 and row 3 to perform operation on something like this. So you get. So let's go. So this is 0 already. So let's go for the next minus 5 and minus 1. So 5 into bracket, what's my row 3? Is minus 1 minus, open bracket, minus 5, which is my row 2. So we have minus 5 plus 5, which is equals to 0. So can you see these three numbers that was here initially, we've turned them to 0, and which is going to make this matrix an upper triangular matrix. So let's go. So we have this. I'm done with the first one. The second one, we are going with the third one, which is minus 4 and 20. So 5 of row 3. What's my row 3? My row 3 is minus 4. Minus 4, close bracket, minus, what is my row 2? My row 2 is 20. So 5 times 4, that's minus 20. Minus 20 minus 20. That is minus 40. Minus 40. So I have minus 40 to the here, minus 40 to the here. Let's check this again. 5 of row 3. What's my row 3? My row 3 is minus 4 and minus row 2. What's my row 2? My row 2 is 20. This is my row 2 and that is 20. So 5 times 4 is 5 times minus 4 is minus 20 minus 20. So that is minus 20 minus 20, which gives me minus 40. So let's do for the last one and we finalize everything. So let me erase this part. Let me erase this part. So I said performing operation on row 3 such that 5 of, I'm working on the last one, which is minus 5 and 15, which is 5 of, what's my row 3? My row 3 is minus 5. Minus 5. 5 of row 3 minus, what's my row 2? Minus 15. Minus 15. So 5 times minus 5 is, 5 times minus 5 is minus 25 minus 15. Minus 25 minus 15, and that is what? 5, that's 0, that's 40. Minus 40, minus 40, so that's minus 40. And this is what we are going to use to get a solution to the initial matrix that was given. So let me write the question so that we are going to, no, let's just solve it. Let's just finish complete. Let's just complete finish. Let's just finish solving. So I will erase this and say, so I will form a new equation with this final something. So let's just take it like this. This is the diagonal. This is the diagonal that I was talking about earlier, and I've turned what was here initially to 0, 0, and 0, which makes this matrix an upper triangular matrix. Upper triangular matrix, which makes this an upper triangular matrix. So I'm going to be forming another new equation with this, and I'm going to solve it, and that is all. So I have this, I have minus 3. Remember, this side is x1, this is x2, and this is x3, and this is my output vector matrix. This is my output vector matrix, which is 12, 15, and 40. So let's go. So I'm going to write minus 3x1, which is this, plus 2x2, which is this, and plus 4x3 equals to 12, which is this. I'm going to write, okay, my x1 is 0 already, my x2 is going to be minus 5, so I'm going to start minus 5x2 plus 20x3 plus 20x3 equals to 15. So equals to 15. I'm done with that. So 0, 0, 0. So 0x1 is still 0, 0x2 is still 0. I'm going to start this one. Minus 40x3 equals to minus 40. So I'm done. This is my first equation, this is my second equation, and this is my third equation. This is my third equation. So I'm going to say from equation 3, I'll just make x3 the sorted of the formula. So making x3 the sorted of the formula from equation 3, so I'll just say x3 is equals to 1, because if this minus 40 cancels this, that's 1. So we are left with 1. So x3 is 1. So substituting x3 is equals to 1 into equation, let me take this off so that the board is going to be kind of clearer. So set x3, my x3 is equals to 1. So substituting x3 equals to 1 into my equation 2 to get the value of x2. So I have minus 5x2 plus 20x3, which is I set to be 1, is equals to 15. So minus 5x2 plus 20 equals to 15. So minus 5x2 equals to 15 minus 20. That's 15 minus 20. That's minus 5. So minus 5x2 equals to minus 5. And my x2 equals to 1. My x2 equals to 1. So I already have x3 to the 1 and x2. So my x2 is equals to 1. My x2 is equals to 1. So I'll say, let me remove this. So I'll say substituting my x3 and x2, which is equals to 1, 1, into equation 1 to get the value of x1. We don't have x1. We already have x2 and x3, but we don't have x1. But to get the value of x1, we have to substitute the value of x3 and x2 into equation 1 to get the value of x1. So let's go. So minus 3x1 plus 2x2, which is 1, 2 into 1, plus 4x3, which is also 1, is equals to 12. So minus 3x1 plus 2 plus 4 equals to 12. So minus 3x1 plus 6, 2 plus 4 is 6, equals to 12. So minus 3x1 equals to 12 minus 6, minus 3x1 equals to 12 minus 6 is 6. So x1 equals to minus 2. So comma x1 is equals to minus 2. So I'll erase this. And just come to this place and see. So therefore x1 is equals to minus 2, x2 is equals to what? 1, and x3 is equals to 1. And that is the solution to the linear equation by using elementary system. So to check, to confirm what you have done, if it is right or wrong. So we do this. To confirm what you have done, if it is right or wrong. We do this. You say, okay, this is the question. This is the question. The first linear equation that was given from the question is minus 3x1 plus 2x2 plus 4x3 equals to 12. And we already got x1 to be equals to minus 2, we already got x2 to be equals to 1, I already got x3 to be equals to 1. So we substitute it into this stuff. If it gives us this 12, then we are correct. So we say minus 3 into bracket minus 2 plus 2 into bracket 1 plus 4 into bracket 1. So minus 3 times 2, that's 6, plus 2 plus 4. So 4 plus 2 is 10. 4 plus 2 is, so 4 plus 6 is 10, and this is 12. This is 12, so we are correct. So let's test the second one. We've tested the first one and it is correct. So let's test the second one. You can just try to substitute it into the 3 equations that was given initially to check if you are correct. So let's check the second one. It says x1 minus 2x2 equals to minus 4. So what's my x1? My x1 is minus 2 minus 2 minus 2 into bracket. What's my x2? That's 1, which is equals to what? Minus 2 minus 2 equals to minus 4. So we are correct. So let's check for the third one. The third one from the question is what? Is 2x1 minus 3x2 plus 4x3 equals to minus 3. So let's substitute our x1, x2, and x3 into this linear equation to see if it is going to give us minus 3. If it gives us minus 2, then we are correct. So what we have solved is very, very correct. So let's say 2 into bracket was like x1, that is minus 2 minus 3 into bracket was like x3, that's 1, plus 4 into bracket, this is x2, sorry, or it's still minus 1, it's still 1 rather, so into x3, which is 1, is equals to 1, 2 times minus 2, that is minus 4 minus 3 plus 4, and this can cancel with this and it's going to remain minus 3. So this is the solution to the linear equation using elementary system. Like, comment and subscribe. Thank you.